Okay, so let's go through one of these. I wonder if I put that right up there. Or could I put that right there? Maybe I'm gonna try that. Okay, here's, oh, you can't see that, gosh. All right, so what do we got going here? We want to, we're just solving, using the best method to find all the complex solutions, right? So what are we going to do? We've got this quadratic equation. Now, we got to get into a pattern here. What do we always do with the quadratic equation first? Say it again. Set it equal to 0. We got to put it in standard form, right?
Wait, what is that asking us?
We're supposed to find all the complex solutions. Okay, so we're just solving this thing. So we'll add 2 to both sides, and then if we add 2 to both sides, aren't we just going to end up with x squared minus 11x plus 3, right? Okay? Let's just say this. Let's not even mess with completing the square. Okay? I mean, it's not that much better in the best circumstances. It's not that much quicker than hey, put that away, please, than doing the quadratic formula. So if we can't find magic numbers, let's just do the quadratic formula. Well, are there magic numbers that multiply to 3 and add to negative 11? No chance, right? So we're just going to use the quadratic formula, okay? So what is the quadratic formula? Quick. X equals?
Negative b plus or minus square root b squared minus 4ac divided by 2.
Okay, so let's plug in our stuff in. So if we plug in our numbers, that's going to give us, what, x equals, what's negative b? 11, just 11, right? 11 plus or minus square root of 11 squared, so 121, minus 4 times 1 times 3. What's that? 12. All over 2, right? So that's not gonna, we're not gonna be able to simplify that, are we? 121 minus 12 is 109. That's not a perfect square. So we know we're gonna get a radical in there, right? So we might as well split up those terms. Only time we would ever leave a common denominator is if I end up with integers on the top that I can add and subtract easily, right? Otherwise, we want to just split this apart into 2 parts. So this is going to equal 11 halves plus or minus the square root of 109 over 2. And I don't think 109 is going to simplify at all. I don't think if you do a factor tree, I mean, nothing on that list is going to divide into it, is it? No way. Nope, so we're good. So those are our 2 answers. So let's go ahead and enter them. On these, yeah, I got to do the fraction thing, don't I? Yeah. Plus square root.
You do the fraction bar and then around.
Yeah, that's right. You guys know this better than I do. Square root of 109 over 2, comma, all right, see how we're doing. How about that? Oh, I'm tremendous. How about that? I like that. Good way to start the day, being tremendous.
Like the ones at the beginning?
At the beginning?
Yeah.
Did I? That was number. Oh, how come I'm clear up there?
Yeah. I don't know how to do those. I just don't know how to do the other ones.
I wonder why I'm so far along there. Okay, what about those? Find all real solutions to the linear quadratic system algebraically. Okay, so we can do that. We can do that. All right, so these are all just going to, these are all going to amount to solving quadratic equations. And the part that people may struggle with here a little bit is just setting up the quadratic equations that you're going to solve.
Someone can give you like radical whatever over whatever, and then you can't have have that as an X. It's an multiplication. It doesn't work.
You won't get any square roots of this.
Well, then I can do it now.
Well, I mean, so you may have made a mistake doing the algebra, but yeah, you shouldn't really, I don't think you'll get any square roots. In fact, I know you won't. Because I know the guy that made these problems.
I think it might
I'm pretty
be.
sure there aren't any of those in there. So, what are we gonna do here? Okay, we gotta substitute, right? First thing we got is we gotta find a convenient variable to substitute. Well, look at the top equation right there. That one's already set up where I can substitute x squared for y, right? So the bottom equation then is gonna become negative x plus, and let's just open up a set of parentheses wherever we're gonna make our substitution. And then whatever y is equal to just goes in there, right? So what goes in there? X squared equals 12. So I just need to put that in standard form. So what do I do? Which side am I going to collect everything on? Left side, because I have a positive number of x squareds there. So we get x squared minus x, and I'm going to subtract the 12 to that side. Okay, and now I'm just going to solve that. What are my options for solving it? Quadratic formula always works, right? Could I take a shortcut here? Are there magic numbers? Yeah, what are they?
Yes, there is.
Justine, what are they?
4 and 3.
4 and 3, and which one's going to be negative?
4.
4, good. Because, right, we want numbers that multiply to negative 12 and add to negative 1. So x minus 4, x plus 3. So then what's that tell us our solutions are for x?
4 and negative.
4 and negative 3. But if you look at this system, there's two variables in there, right? So I need to solve for both of the variables. When I'm solving an equation or a system of equations, I need to find the values of all of the variables that make everything true, right? So I need y values also. So really what I'm going to do here is I'm just going to open up an ordered pair. And I know that the x coordinate is 4 there and negative 3 there, right? I just have to find the y values, but that's easy to do because I have a boxed equation up here that's already solved for y, right? So if I plug 4 in for x, what do I get for y? 16. If I plug negative 3 in for x, I get, there you go. Those are your two solutions. Okay? Make sense? Okay. All right. Let's see. You guys tell me, do we want to do that one?
Yeah.
Okay?
I literally don't want to do that.
Okay, I will today for sure. It's been hard to do coaching track, but I'm going to for sure, whether it's today during school or this evening right after track practice, I will make sure that all of my notes and videos are updated for all this stuff. Okay, so you should be able to go to those. You know where to find them, right? Okay, I would hope so. So if you need to start looking at that stuff, I mean, you might need to. And then all the PDFs are up there too. So that's our textbook, right? Instead of making you read out of a big cumbersome textbook and find everything on your own, I've made all the PDFs on top of each assignment. The reading that goes with that is right there, right? And I made them as short as I can. Okay, so what am I going to substitute this time?
X minus 1 squared.
Okay, x minus 1 squared. Okay, that's my substitution equation. So we're going to get 2x plus whatever y is. Well, what's y? Y is x minus 1 squared, right? And that all equals 2. Okay, so this time I have to do some simplifying, right? I have to square out x minus 1 squared. Okay, now be smart about this, right? We worked on these patterns. What pattern is that? If I have x minus 1 squared, you always can just write x minus 1 times x minus 1 and distribute and add like terms. That's the long way to do it, but use the pattern. We've used this pattern a bunch. You guys at this point, I believe, should know this pattern. What is it? What's x minus 1 squared?
X squared
So,
Or
yeah,
when
yeah, okay, good. Hunter's using the pattern, a minus b squared equals a squared minus
2a plus 2b squared.
plus b squared, right? Okay. So then we end up with a is x and b is 1. So I get a squared minus 2ab, so that's just 2 times x times 1, right? So 2x plus 1 squared. So we get 2x plus that equals 2. So which side does everything go on to? Marissa, which side am I going to collect everything on? Left side, good. We already have a positive x squared there. So we get x squared, 2x minus 2x. Look at that, those go away, right? So then I just get plus 1.
Wait,
So-
you're gonna be minus?
Minus, right, I'm subtracting, you're right. Okay, and now, how about this? Whoops, equals 0, not 1. Now, how about this one? How can I solve this one? This is the easy kind, right? Aiden, what can I do with it? Please, please, I'm not gonna ask again. Put that completely away. We don't have time for that stuff. What am I gonna do here?
Add 1 to this other side and then square.
Square root, good, so I can isolate x, can't I? I can point to a single x so I can isolate it. So we get x squared equals 1, so x equals plus or minus 1. But I'm solving a system, right? So you can't forget, I gotta plug that back in and find y. So one ordered pair is gonna be 1 something, and the other one is negative 1 something. If we go up to our boxed equation, if I plug 1 in for x, what am I gonna get for y? Shan, what am I gonna get if I plug 1 in for x? So, but I'm gonna plug my 1 in to figure out what y is, right? So if I plug 1 in for x, what's that whole thing gonna equal? I mean, all I'm gonna do is see, look, x is equal to 1, right? And I'm trying to figure out, I wanna know what's the y that goes with that. So how do I find out what the y is that goes with that? Say it again. How would I mean, you know that, I know you know this, Shane, I guarantee you do. So if I wanna figure out what the y is that goes with an x value of 1, I can use either one of those equations, really, right? How am I going to figure out what y goes with an x value of 1? Not sure? Okay, what do you think? Yes.
Should it be 0?
It's 0. How'd you get that?
1 minus 1, 0 squared is
Okay, yeah, okay, good. I could plug in the 1 there, and I get 1 minus 1, which is 0 squared, which is 0, right? So when x is 1, if I plug 1 in, the y value I get back is 0, right? So we get 0 there. What if I plug in negative 1?
4.
I'm going to get 4, good. Everybody see that? Because I'm going to get negative 1 minus 1, which is negative 2, squared, positive 4. Okay, how could I check? See if I get this right. Plug them in. Yeah, plug them both in to both equations, and if they work, I know I got it right. So on the SBAC test, where you can take as long as you want, you should, every time you're solving an equation, every time, for sure, check it. If you don't get it right, start over. There's no time limit, right? Okay. Let's move on here. Let's see. Okay, that's, I mean, what are we going to do there? Maybe we don't even have to do this one. How are we going to solve this one?
Add 12.
Add
No.
12.
Oh, well,
You're right.
no, can you
Subtract 12.
divide by 3 first?
Well, now hold it. What's the order got to be? You got to do PEMDAS backwards. So you, when you're isolating x, definitely what's the first thing you have to do? Subtract 12. Good, good. So we're going to do negative 3x squared equals 306 minus 12 is 294. Okay. So now if I divide both sides by negative 3, I get x squared equals a positive over negative is negative, isn't it? So I get negative, 3 goes into 29, 9 times with 2 left over, right? So 98. Okay. And now I've just got to square root both sides, right? So we're going to get x equals plus or minus. What do I do about that negative when I square root both sides? Okay, we know we're getting an I. Good. and I've got the square root of 98. And all I have to do is just simplify that, right? So let's make our factor tree. 98. Well, it's even, right? So I know 2 goes into it. So 2 times what is 98? What's half of 100? So what's half of 98? 49, there you go. And 49 breaks up into what? 7 and 7. Okay, well there's a couple, there's a single, right? So we get x equals plus or minus 7 radical 2 I. And I have to put those in separately, but no big deal, right? You guys got this stuff.
Yeah, no, you got a test night, so I don't know what to do.
Well, I think you just gotta
They're
slow
way
down.
harder on the test, I swear.
This is the test. This is the test. I promise you, this is the
Can we take
test.
it right now while it's fresh in my brain?
Okay, so what would I do here? Okay, good, I'm gonna isolate x because I can point to a single one. So what are the steps? No big deal, I'm gonna add 10, then what? Divide by 2, good. Square root, add 3 in front of the plus or minus, good. Divide by 2, done, right? Okay, you guys can do all that stuff. Part of it is, honestly, part of it is just confidence. I know that, like, Marissa, she's answered she popped up stuff, she knows this stuff. It's just a matter of on the test is just being confident. You know the stuff. Just go through the steps. Okay, I'm just gonna put everything in standard form, and what's one option I always have? Quadratic formula. Add it all to the left side and use the quadratic formula if you want to. Actually, let's do this one though. Let's do this one because there's a point I want to make. This is a really easy one. I want you to see why this is easy. If I add x squared to both sides, I get 2x squared plus 6x. If I subtract 7, I just get 0 on that side, right? Now I could. Even here, the quadratic formula is going to work. What's A? 2. What's B?
6.
What's C?
0.
So I could do it that way. It's way overkill, though. I don't have to do that. All I have to do instead, when I have 2 terms, I just want to factor out the greatest common factor. So what's the biggest number I could undistribute? What else could I undistribute? An x. Yeah, when I can undistribute a variable, look what happens. I get 2x times the quantity what? 2x times what is 2x squared? X. 2x times what is 6x? 3. Yeah, right? So look at that. Now, what are my zeros going to be? Look at my factors. What's the red 0 going to be? Negative 3. The blue 0 is easy. What's that? What's the value of x that's going to make that whole thing 0? Duh.
0.
0, yeah. Whenever you have a monomial factor like that, that's just something times a variable, it's always going to give you back 0 as the solution.
Wait,
See what I'm saying? Well, all you ever have to do here when you're you do this in your head, but when you're applying the zero product property in your head, you're solving an equation. You're setting each factor equal to 0, right? So when you told me it was negative 3, what you actually did was you solved that equation, right? You set it equal to 0 and you subtracted 3 from both sides. So there's my x equals negative 3. Well, what about this guy? If I set 2x equal to 0 and solve, what's the answer? 0, right? Okay, see what I'm saying? Okay. Okay, quadratic formula, right? Or maybe complete the square, factoring. But you can always use quadratic formula. Even if you can factor, quadratic formula still would work. It's just a little harder, right? Same thing, put it in standard form, quadratic formula, right? You got it?
Let's take this test.
Okay, I think you're
Except
you're
we're
ready
gonna
to
have
go.
to like redo it it, because like I already got 3 wrong on the last.
Just
so,
restart it then, that's fine,
Yeah,
just
I'll just
restart it.
actually, I think I only got 2 wrong. You got 1 right. So maybe I can just.
Same thing, right? I would just quadratic formula, put it in standard form and quadratic formula. This ought to be, seriously, honestly, don't you think, why don't you guys just all go get 100 on this thing? I mean,
Okay, no problem.
why not?
Yeah. I'll do that. Then I'm gonna take it.
Okay, I wasn't planning on this at all today. But I'm gonna let you guys have the rest of the period to take a test, get this done. Because you only have a few more days before these all go away.